Okay, in the VLSM problems, we always start with the largest and we go to the smallest, and we have different size networks for each of the different networks here, and we have to take into account the point-to-point network. Now, I've already put these in order from largest to smallest. It's actually better if the student did that themselves, but in this case, I've given it to them. So we're going to start here with this production network, and we have to find out what that network is. And this is the network ID, the 192.168.1. Whoops, I didn't mean to type it there, 192.168.1. And so we'll start with, of course, the 0 for the first network address. All right, we need, in production, we need 125 hosts. In order to get 125 hosts, I could use this one right here. So that means I'm going to increment by 128 in the fourth octet. So 128 in the fourth octet, 192.168.1.128. And that, by the way, was a /25 or 128 in the fourth octet for the subnet mask. Or /25. All right, for management, we need 16 hosts. So let's take a look here for 16 hosts. I can get rid of that one. 16 hosts, well, I can't get it out of this one because I can only get 14 usable hosts out of that. So I'll have to go with this /27, which is the 224, 255.224, or /27, and that would give me increments of 32 in the fourth octet, if I were to highlight that. Okay, 32 in the fourth octet. .192.168.1. Let's see, 32, 3, 4, 5, 160. For sales, I need 5 hosts. Well, I can get 5 hosts out of, I can't get it out of this one. I could get it out of this one. So that would be the 29 or the 248 in the fourth octet. Or /29. And that would also mean an increment of 8 in the fourth octet. So 8 in the fourth octet, 192.168.1.168. All right, for research, I need 4 hosts. I can't get it out of this one because I can only get 2 hosts out of that. I could get it out of this. So that's the /29 or the 248 in the fourth octet. Or /29. And that means also that I'm going to increment by 8 in the fourth octet. Is that right? 8 in the fourth octet? Because I needed, let's see, 4. Yeah, so 8 in the fourth octet. 192.168.1. What would that be? It would be let's see, 168, 176. Yeah, that's right. Now for HR, let me see, HR, I need 3 hosts. Well, again, for 3 hosts, I can't get it out of this because I can only get 2 out of that one. So I'm going to have to stick with this and go 8 more in the fourth octet. So we're going to use the same subnet mask, and we're going to go up by 8 more. So 192.168, I said 0 on this other one, I meant 1.1, that looks a little bit better, let's see, 184 that would be. And then for the peer-to-peer, or I should say point-to-point, not peer-to-peer, point-to-point network, that is always going to be a 252 here, slash 30, or 252 in the fourth octet, and it's always going to have an increment of 4. So we're going to go 255.255.255.252, or that's the same as slash 30. And we're going to go up 2 more here, 192, or I mean 4 more, .168.1.188. All right, that gives us a broadcast address here of 1.127, 192.168.1.127. And here, let's see, 160, so that makes it 159. 192.168.1.159. The next one is a 168, so that would make that 1.167. I keep putting zeros in there. I don't know why I keep doing that. 168.1.167. And the next one looks like 175. 192.168.1.175. Next one looks like a 183. 192.168.1.183. And the next one would be a 187. 192.168.1.187. There we go. I can just take all of these and put them in the last usable, and then I can just deduct 1 from each of these. 6, 8, 6, 4, 2, and 6. And then the other thing I can do is the opposite over here, get all the network addresses, and then increment them by 1. 1, 9, 1, 9, 7, and 5. And that one is complete. Okay, for the second problem we have this topology, and it looks like Seattle is going to be first. Let's get our network address. This is the network ID is 10. And so if we fill out the rest of the zeros, that is the first address of our network address. All right, Seattle needs 60 hosts. So let's take a look at Seattle at 60 hosts here. It looks like we can use this one right here. So that would give us 64 in the fourth octet. 64 in the fourth octet, 10, 0, 0, 64. And that was, you know, if I do this, then I should be able to switch back and forth quickly. And that was 192 in the fourth octet, or slash 26. So 255.255.255.192 or slash 26. There we go. Portland needs 50 hosts, so that would be, well, that would be the same one. I could use this one. That would be an increment of another 64. So 10.0.0.128, and we used the same subnet mask. Chicago needs 30 hosts, so that would be right here. I don't have any room for expansion. I only get exactly 30 hosts, so hopefully they don't need any expansion. But that would give me a 32 increment in the fourth octet. So 32 increment, 10.0.0. What would that be? 8 plus 2 is 0. Carry the 1. What did I say? 33, 4, 5, 6, 60. 160. And that was a 224 in the fourth octet, or slash 27. 255.255.255.224 or slash 27. All right, Salem. Salem needs 25 hosts. Well, I can use the same one for that. So I'm going to go 32 more in the fourth octet. So 10.0.0, and I need 32, so that would be 6789192. And I used the same subnet mask. Main needs 10 hosts. Well, that would be, I can use this one for main. I can use a /28, and that would give me an increment of 16. So let's see, 10.0.0. I need to go 16 more. 6, 7, 8, 9, 10. So what would that be? 201? Would that be right? I don't think I'm doing that right. 192, 208. 208. There we go. And that one was a /28, which is 240 in the fourth octet. 255.255.255.240 or /28. Now for our point-to-points are always going to be a /30, or which is 252 in the fourth octet. 255, 255, 255, 252, or /30. And that's always going to be, again, that's always going to be 4, increment of 4 in the fourth octet. 10.0.0 is 212. Oops, 212 like that. All right, that'll give us our broadcast addresses. So 10.0.0. Make sure I did this right. See, all these, I did all these wrong. It should be 10.10. 10.10, 10.10, 10.10, 10.10, 10.10. All right, that's better. Good thing I checked it. So that's going to give me 10.10.0.211 for a broadcast address. This is a 207, so 10.10.0.207. This is a 192, so that'd be a 191. 10.10.0.191. 160 would be 159. 10.10.0.159. 128 becomes 127. 10.10.0.127. And then 64 becomes a 63. 10.10.0.63. Now that it makes it really easy then to get these last usable by just subtracting 1 from each one. 6, 8, 190, 206, and 210. It also makes it real easy for me to get the first usable addresses by just adding 1 to each one of these. 165, 129, 161, 193, and 209. And I always warn students not to, when they think they find a pattern, to be careful not to necessarily go by it. But it is always true, as far as I've ever discovered, that network addresses are always even. First usable is always odd, broadcast is always odd, and last usable is always even. And as far as I can tell, that would always be a pattern. All right, let's go on to this third one now. This one can be a little tricky. Given the following point-to-point network, what is the address of the unknown router? So we have a point-to-point network. And as we said before, point-to-point networks are always going to be 4s. They're always going to be increments of 4. They're always going to be a /30, or which is 252 in the fourth octet for the subnet mask. And so that should make it pretty easy, because all we really need to do, whoops, I hit the wrong one. I didn't mean to hit PowerPoint. I meant to hit Excel and give us a new Excel spreadsheet. New spreadsheet. There we go. So we're always going to go up by 4 in the fourth octet. So let's look at where our starting point is here. We're starting with, we have a 137, 188, 16. 137, well, I don't care about that part actually. I'm working in the 4th octet, so I'll just put a 0 and then a 4 because I'm always going to increment by 4 in the 4th octet. Alright, so if I carry this down, let's go down a little bit farther. There we go. That's as far as I'll need to go. I see that 122 is going to be one of the addresses. So 122, so that puts me in this one. If this is the network address, then 121 would be the next one, 122 would be the next one, and the broadcast address would be the 123. So that tells me now that the 121 and 122 are going to be the two addresses in that. So I've got the 122, so this is going to be the 121. 137.188.16.121. The last valid host on the network, that 10, 236, 108, 208, 255, 128, 0.0 is part of. So we need the last valid host. All right, well, we have a 255.128.0.0. So let's go over to this and look at where the 128 is in the 2nd octet. So we are talking, and I'm going to use this one for this. I don't know why I have this particular problem in the 4th octet VLSM, but I do. So let's see. I said 2nd octet. 128 in the 2nd octet. So that puts me here in this particular column. So that tells me that I'm going to increment by 128 in the 2nd octet. So let's go back to our problem. I'm going to go by 128 in the 2nd octet. So that would give me 10.0.0.0 as our starting point, and then 10.128.0.0 for the next address, or for the next network. And so that tells me then that this network, let's see, 236, that's going to be on this network. And this network is going to, I can't do another 128 because I would be at the upper limit of this thing. So that means that the broadcast address of this thing is going to be 10.255.255.255. And I wanted the last valid host on the network, so that's going to be one less than the broadcast address. So that's going to be 10.255.255.254. So this is going to be our solution right here. And I always encourage students to give me the CIDR or the subnet mask. And in this case, we have a CIDR of 9 or a subnet mask of 128 in the 4th octet, or excuse me, 128 in the 2nd octet. So that's a /9. And I don't count anybody wrong if they don't give me the slash here. I should take the spaces out of there to be proper, and I'll get rid of this stuff. Alright, given the network below, what would be the network address and subnet mask or CIDR for subnet C? Well, let me see here. We got to put these in order. We are going to be doing D, A, B, C. So D, A, B, and then C. Well, of course, it would be the last one, wouldn't it? So we're going to start here with 192.168.1.0, 2.168.1.0, and we're going to add 61 hosts. Well, in order to get 61 hosts, it looks like, well, let's move these things out of the way. And let's turn this black again. There we go. In order to get 61 hosts, it looks like I would use this column right here. So I'm going to increment it by 64 192.168.1.64, and I should make note that that was a /26. All right, to get A, I need 29 hosts. That would be here. So I'm going to increment by 32, and now it'll be a /27. This is going to be a /27, and I'm going to increment it by 2, 192. What I said 2. What did I say 2 or did I say 32? 29 hosts. So by 32 in the fourth octet. Okay. 192.168.1 let's see, 4 plus 2 is 6, and 96. Okay, 96. Now B is going to be 21 hosts, so it looks like I have to use this one again. I'll have to use another /27, and that means I'm going to increment by another 32. So that would be 192.168.1.128, and whoops, and C is going to be 12 hosts. So if I need 12 hosts, then I will need a /28 for that one. /28. So that gives me, I needed the network address in the subnet mask, so that would be this number right here, 192.168.1.128, and this would be a /28, which is the same as 240 in the fourth octet. 255, 255, 255.240, or /28. All right, so that's the end of this one.